Okay.
Good morning and good afternoon. My name is Aaron Smith. I'm the CEO of the Energy and Environmental Building Alliance, or EBA, and I'm excited to be joined today by our sponsor, DuPont Tyvek. Today, we'll be learning about tips for installing a weather-resistive barrier. And I think one of the biggest changes for me as I did new windows and Tyvek on my house this past fall was the eye cut versus the upside down martini glass, many of you remember. So lots of great tips and tricks to learn today. I am fortunate to be joined by Keenan Watson. Keenan is the Field Development Specialist for Residential out of Richmond, Virginia, and Samantha Combo. Samantha is the Field Development Specialist for Multifamily out of Denver, Colorado. Welcome to both of you. And we don't have,
thanks, Aaron.
By the way, Samantha's camera's not working, so we don't have her on video. So you'll see Keenan more. And I'll be available and curating questions as we go, but take it away.
Perfect. Well, thanks everyone for joining this webinar today, and special thanks to Aaron and Nancy for giving us the opportunity to host today's session. So today's presentation will cover the whys and hows of using continuous insulation with a separate weather barrier and how to properly integrate those systems. So I'll be starting off today by talking through some of the benefits of using CI on homes. And then in the second half, Keenan will discuss some tips on how to install it either over or under your weather barrier to ensure you have proper air and water holdout for your building. So to begin this presentation on why and how to use CI in conjunction with the WRB, I first wanted to start off by talking about why these are important topics to have a good understanding of. So in 2018, the International Code Council, the ICC, and the National Association of Home Builders, they published a joint survey report which highlighted some of the most common violations that had been flagged by code officials in order to help guide builders and remodelers to areas that they can focus on, not only to improve the quality of construction before and during a build, but also to ensure that the provisions of the energy code are being followed. So what we wanted to highlight here is that within the top 5 most common issues found, improperly sealing penetration through the walls, as well as not using the suitable amount of cavity and continuous insulation values to meet code, were found to be 2 really prevalent violations. So with this presentation, we'll be addressing both of these considerations by touching not only on what the benefit in using CI is in residential buildings, but also how to properly integrate it with the WRB layer at your rough opening conditions, as well as properly sealing any penetrations to ensure that you have water and air holdout for your building enclosure. So before going into why using continuous insulation is a best practice, I first wanted to start off by covering the basics of exactly what continuous insulation is. So continuous insulation, or CI, as it's usually abbreviated, is defined as any insulating material that's going to be continuous across all your structural members outside of your typical service openings and your fasteners, which are allowable by code. So for insulation to be considered truly continuous, it needs to be placed on either the interior or exterior face of your studs. So this means that it's not being sandwiched by framing members in the same way that, for example, fiberglass bat placed in your cavity would be. 3 of the most commonly used CI options for both residential and commercial construction in the market today are expanded polystyrene, or EPS, extruded polystyrene, or XPS, and then we also have polyisocyanurate insulation. It's commonly shortened as ISO or polyiso. And the main differences in between these options is primarily with their cost and also the thermal resistance or the R value per inch, which they provide. So to really understand the benefit in using CI versus solely cavity insulation, you may have heard the analogy that using cavity insulation in a building is kind of like eating your sweater to stay warm on a cold day. So of course that wouldn't be a practical way of warming your body up, and you instead obviously want to wear your sweater. So the same principles apply to your building. So think of CI as kind of like the sweater that keeps your home or your building from losing heat and helps it perform a lot more energy efficiently. So I just want to give a broad overview of some of the benefits in using continuous insulation and kind of give a sense of what's driving its use in the residential market. So this is definitely not an all-inclusive, all-encompassing list, but I just wanted to highlight some key items here. So first, you're likely aware of the IECC, or the International Energy Conservation Code. And this code sets requirements for building design, materials, and performance in terms of energy efficiency. So we have new updates of this code being released on a 3-year cycle, and then each iteration is adopted by different states and different jurisdictions at their own pace. So code changes have really been a driving force around using CI, and it's really interesting to see the shift towards its use these days, when just about 20 years ago, it was still not a really commonly used practice. So using CI in buildings first started gaining traction within the commercial construction market with code updates there. And then it eventually started becoming a recommended option in residential code as an alternative to what was traditionally done, which was, putting bat in the cavity of either a 2x4 or 2x6 wall. So going into energy savings and comfort, CI contributes to both. And it's important to realize that thermal insulation reduces the amount of energy that's needed to either keep an air-conditioned space cool in the summer or a heated room warm in the winter. So all of these things play into the overall thermal comfort of a building for its occupants. And it's also gonna reduce the amount of money that's spent on utilities needed to maintain a certain internal temperature. So this is gonna translate into the homeowner keeping more money in their pockets, which is always a good thing. So what makes CI different than cavity insulation is that it's a little bit more effective in improving the total energy performance of a building. And the reason behind this is because CI mitigates the effects of heat loss that's caused by thermal bridging. So thermal bridging is a phenomenon that occurs whenever you place a cavity insulation solely in between highly conductive framing, such as wood or steel studs. And because heat always wants to travel along the path of least resistance, it's gonna want to travel through the framing if you don't have anything stopping that heat transfer. So thermal shorts are a major source of heat loss within a home, and it overall reduces the efficiency of the insulation itself. So a solution to this issue is to use CI and ensure that it's not being interrupted by any framing. So this slide is showing the 8 different climate zones across the US that are recognized by the Energy Conservation Code and the associated R value requirements for each zone. So just as a side note, each of these climate zones were divided up in terms of the unique heating, cooling, and also humidity characteristics of different parts of the country. And to be able to reach goals set forth to make residential buildings more energy efficient, new code iterations tend to have increasing minimum R value requirements. And there's greater adoption of the use of CI to achieve this. So you can see here on this prescriptive R value table, for example, back in 2006 with the Energy Conservation Code in Climate Zone 3, There's only a requirement to have R13 in the cavity, but with the newer 2015 code, the requirement has been increased to minimum R20 in the cavity, with the option instead to put R5 continuous insulation on the exterior and use a little bit less in the cavity, so R13. So code changes are clearly a big driving factor in the use of more CI in residential buildings moving forward. And they've really been recognized as an easy way to improve the overall energy performance of building enclosures. And then something I just wanted to mention here is that this table is showing the prescriptive R value requirements. However, there are other ways of meeting code and demonstrating that compliance. You have the performance approach, where essentially the designer would show that the whole building performs to a certain standard or better. And then you also have the prescriptive U-factor approach. So there are U-factor tables in the Energy Conservation Code as well. And it looks at the thermal performance of the wall assembly as a whole. So this gives designers a little bit more flexibility in terms of the amount and also the location of the insulation that's used, as long as the maximum U-factor for the assembly type isn't being exceeded. So just wanted to mention that to show that you have other ways of showing code compliance, and you're not totally restricted to using only the R value approach that's shown here. So as I previously mentioned, one of the benefits of using CI is that it helps mitigate the effects of thermal bridging, which again is caused by heat traveling faster through more conductive materials, for example, your framing. And this leads to areas in your building where the insulation isn't going to be able to perform as effectively as needed, and your home is going to be losing energy. So framing alone really does have an ability to reduce your total wall's insulating value, and this can be up to 30%, which is, very significant. And you might be wondering, how does framing lead to such, significant energy loss? So this is because framing members really make up a really large portion of a building. So if you think about all the wood for a typical home, or the amount of wood that's used to build a home, you're not only going to have wood around your door and your window openings, but it's also going to be spaced every 16 or 24 inches on center. So once you add all of that up, it's really easy to see how substantial framing, the impact of framing on your overall building. So as a result, the R value of wood is much less than the R value of insulation that surrounds it when you're placing it solely in the cavity. So these framing members are all going to access areas of high heat transfer, hence you start losing energy across that thermal bridge. So again, a better approach here is to use CI either outboard of your studs on the exterior or on the interior, and this will help combat the issue of thermal bridging and improve your home's overall energy efficiency as a whole. So let's look at a real life example of this. So here was a picture that was taken of the home, and it kind of gives you a visual of the effects of thermal bridging when you're only insulating on the cavity as opposed to insulating on the exterior as well. So what's happening here is that you have moisture developing on the surface of the stucco everywhere that the wall is losing a ton of heat because of that thermal bridging phenomenon. And that's making the wall surface a lot colder. And then whenever you have moist air touching a cold surface, this is going to result in condensation, and it's what's being shown here in this image very easily. So by using continuous insulation, this condensation would have been much less likely to occur. So another important consideration with any building is preventing moisture from developing in critical areas where it'd be very difficult to dry out. So we've all seen how much damage moisture can cause in a building when it comes, or it occurs in undesirable areas, which can lead to all sorts of problems, which can range anywhere from mold and mildew growth to R value or structural degradations in really extreme cases. So when you're thinking about what causes condensation, it's really important to realize that because air is full of moisture, anytime you have air infiltration or exfiltration into a building, that's going to be a means of transporting that moisture. So an interesting fact here is air leakage has the ability of bringing nearly 100 times more moisture into a building enclosure than through the process of vapor diffusion alone. So that's all part of the reason why you want to always ensure that you're using proper air sealing techniques when you're trying to combat moisture. So while we can't do much about eliminating moisture from the air within an enclosure, if you think about a typical household, you're going to have sources of vapor and humidity constantly, whether that be from people showering, cooking, doing the laundry. You know, all of those are sources of humidity within your building. However, there's one thing that can be controlled, and that's going to be temperature, specifically the temperature of any critical surfaces, and making sure that that temperature is above the dew point temperature of the air. So that brings me to a really important property, which is the dew point temperature. And that's going to be the temperature at which the air can no longer hold on to the water vapor molecules that's mixed within it, and then it has to start condensing out. So one way to ensure that condensation isn't occurring in critical areas, for example, you know, behind your drainage plane on your sheathing or within the cavity itself, one way to prevent condensation in these areas is to ensure that those surfaces are going to stay well above your dew point temperature. So this is where using continuous insulation can help. So CI has the ability of changing the temperature profile of your wall by warming it up. And that's going to, in turn, reduce the likelihood that any of those critical area surfaces will have temperatures that fall below the dew point temperature, which, as you now know, can lead to condensation developing. So that's yet another benefit in using CI on your building. So now that I've covered kind of the fundamentals on the impacts in using CI, which are not only improving energy efficiency for your home, but it can also prevent moisture development, I just wanted to show a real-life example of this. So back in 2011, the thermal side of our business, which at the time was known as Dow Building Solutions, they built 12 research homes in Midland, Michigan, through a partnership with a local home builder named Cobblestone Homes. And they did this to analyze the moisture and energy performance for these different homes. So they had 3 different floor plans, as you can see here on this slide, and they were built to satisfy 4 different energy performance strategies. And then one quick side note here is all of these homes were rental properties that were occupied over the course of this multiple year study.
Hey, Samantha?
Yep.
We had a question come up that it's probably from 2 slides ago, but what about continuous insulation in humid, warm climates? Is there kind of a different way of thinking about it with the dew point, or is it fairly similar?
Yeah, that's a good question. The properties and the characteristics are pretty much similar across all climate zones. With continuous insulation, essentially you're kind of manipulating the location of where your dew point is going to be located. So in a hot, humid climate, if you put your CI upward of your studs, you're essentially reducing the chance that any moisture that gets into your building, it reduces the chance of that moisture to actually condense into liquid water. So in a hot, humid climate, obviously the exterior is going to be filled with that moist air, and your continuous insulation is essentially preventing it from getting into your colder building environment. So it's essentially stopping that progression of moisture into the the interior.
Great, thank you.
Yep, thanks. So with this case study, what they had 6 homes that were built using 2x6 framing. They had R19 craft face fiberglass bat, OSB, and a separate WRB. And the first consideration looked at a building envelope that had no CI. And then they had 3 homes that were built with 2x4 framing, but they had R5 CI. So an important note here is that all these homes were located within the same neighborhood, and they had below 3 air changes per hour. So there really wasn't any significant difference in the moisture entering the cavities via air leakage. So here's an image of the apparatus that was placed midway up the wall within each home to record the temperature, as well as the relative humidity and moisture content of the interior surface of the OSB. So that's kind of how they recorded all of the parameters. And this slide shows the recorded moisture content for the 6 homes that were built with only bat insulation and had no continuous insulation over a 3-year period. So the average of the results of all these homes is shown in the red. And then I've also indicated here with this green line, the 20% moisture content mark, which highlights ideally the moisture content that you want to keep wood below. So in this case, the OSB sheathing, in order to avoid having to worry much about decay or mold development. So to explain some of the results that we're seeing here, one note here is that even though the first winter was fairly mild, most of these houses that were built without continuous insulation went above 20% moisture content for about a 2-month period. So in other words, for about 1/6 of that year, the OSB was wetter than would have been ideal. And then you can see year 2, the next winter, it was actually one of the coldest on record. And this caused 5 out of the 6 homes analyzed to register a really high moisture content value from between around December to April. And then the last winter in year 3, it was closer to average, but again, most of these houses registered very high moisture content values. So since the general trend was that the colder the exterior temperatures, the higher the moisture content recorded, it could be assumed that there was indeed some condensation occurring on the interior surface of that exterior sheathing for these homes. And you can see that there's one outlier here in the teal, which stayed below that 20% moisture content mark every winter. So just a fun fact here, the person renting that home was actually an elderly individual who was living on their own. So it kind of makes sense that that house would be registering lower moisture content values than the others, especially compared to a typical 4+ person household. So while it isn't possible to build homes without CI that can work, it's definitely more likely, as shown with these results here, that you have increased potential for condensation. And on the other hand, here are the 3 homes that were built with the CI on the exterior over the same 3-year period. And you can see the big difference here. All 3 homes were below that 20% moisture content mark, and they all performed fairly consistently without much variation each winter. So in comparing these results to the previous scenario, hopefully this helps give you guys a sense of why controlling temperature by adding CI is, it's really an effective way to control the potential for condensation within the home. And then lastly, to wrap up the benefits in using CI, I just also wanted to mention basements, which are an area of the home that are equally as important to insulate. And they can actually account for about 20% of a home's total energy or heat loss if left uninsulated. So this is because you have really large uninsulated surface area, both below and above grade. And since basements are typically going to be made out of either concrete or CMU, those materials are notoriously poor at insulating. So to put that in perspective, concrete actually has a thermal resistance that's similar to a single pane of glass. So it's really no surprise that heat can flow very easily through the material when you're not insulating it. So because of this, it only makes sense to address your basement areas with CI, either on the exterior or the interior of your walls, to help reduce that heat flow and increase the overall energy efficiency for your home. So there are pros and cons of insulating on either side of the wall, but both approaches will really help you mitigate some of the energy loss you experience when your concrete is left totally uninsulated. This picture here kind of shows and gives you an idea of how drastic that energy loss can be if you do leave a basement without some type of insulation in comparison to the rest of your home. So that wraps up the whys of why it makes sense to use CI for a residential building. So with that, I'm gonna pass it over to Keenan to discuss some considerations when it comes to integrating CI with a separate water barrier.
Samantha, quick question, if I may. On your second house example, the SFP, or sorry, SPF, was that what type of insulation was that specifically?
Yeah, I believe at the time that was one of Dow Chemical's spray foams that they produced at the time, but
do you know if
they no longer
do
manufacture.
you know if it was a closed cell or open cell?
They were all closed cell
Okay.
spray foams that Dow used to make.
Thank you very much.
Yep.
Obviously, I'm muted there. Thanks, Samantha. I think you showed a ton of reasons on the whys to use thermal, and I'll go through the hows now. So there's a lot of thinking involved when you're putting up wrap and foam. So we, on the Heritage DuPont side, and you'll hear a lot about bringing these two companies together and having a full portfolio of products. But at the time, with our DuPont Tyvek, we didn't think thoroughly through for the thermal. So it wasn't a part of that portfolio. But what we understood was builders were doing that. And now we've been able to combine these products and show with our installation bulletin a pretty robust installation guidelines that go into depth about it. So this slide right here may not mean a lot to many, but internally it does, because we understand that, like she said, with codes driving it, with builders just learning more. So we have a lot of tools in which you can learn why thermal is important. And Samantha touched on a lot of that. We needed to upgrade that and come up with a more robust install bulletin board. Next. Through this, I think there are 12 burger dots, and you can see on this slide, I'm going to focus on 4. Does that mean the others aren't important? No. It just means for the time that we have, I kind of want to focus on the 4 that most of you would notice on a day-to-day basis, being out on job sites, architects, builders, whatever you may be. And those are going to be your general considerations. So these are things you want to think about before you get to that job, whatever that job may be. That can range from, is it a new construction? Is it a remodel, but you're leaving the windows in? Is it a remodel, taking windows out? A lot of considerations will go into what type of process you're going to use when combining wrap and foam. And I want to touch back on that. This is focused on our products, obviously, because we've tested the combined portfolio. We know it works, and we're really confident with our products. But don't think that this can't be some other combination of products, as long as that warranty is followed and you're doing the correct installs. I think it's important for us to teach and present on correct building science and the correct construction. But obviously, we love our products, we believe in them, but don't think others can't be used. The second one, fasting consideration. So This is a pretty important one because if you think that, hey, I've only used wrap, but now my code's changing, now my mentality's changing, I want to start using foam. Well, now I've got to change up the way in which I fasten the whole system. So I have to think that through and not be stuck on the job site. The next one is ceiling penetrations. And I think this one is not talked enough. I just don't think people discuss it enough, and it's kind of just kicked to the side. I go on way too many job sites where I see, whether it be a pipe penetration, whether it be a electrical box, that somebody might just put a sealant bead around it. And we all know sealant will not last the lifetime of a home. Or they'll origami some construction tape and call it quits. So we have to understand that that's a pretty large air loss, or can be potentially the size of the home and how many you have. But also an interface where you can have moisture intrusion and only cause problems down the road. And then lastly, I'm going to talk about the install sequences for windows, whether that be nail flanged on windows, recessed windows, and then that can also be in touch with doors too. So a lot goes into that, and I'll show 5 sequences that we see heavily and prevalent in the field, and maybe things that you can think of if you want to change construction, or you might think about changing construction, things to think about. Next. So we'll start off general considerations. And again, I talked and touched base on, think about it on the job site you're going on, or an architect, whatever you're recommending for that job site. So not what you've been doing is always right. So we hear, and I'm on the roof also, I hear a lot about, well, my dad did this, or our company's been doing this forever. There's always room for improvement, and maybe you'll learn something or see a trick that, wow, I haven't thought of that. Maybe our process isn't the best. It's not wrong, but maybe we can improve it in some way. But you always want to make sure that that WRB, whether a wrap it is installed on the same plane as the window, so that the flanges have an easier integration with the flashing. This is key, and it's that whole process, and we preach it at DuPont, of correct shingling. We always say you don't want to tuck in your rain pants into your rain boots. It kind of defeats the purpose of holding out that rain. Why would it be any different on the side of the home? So you want to make sure that you have that continuous plane and you have it shingled correctly. But a lot of words, and this is because it's coming from a bulletin. You can focus on some of the things on the right that, like I said, WRB installed on the same plane, but that the WRB can be over or under. And you'll also hear on top or behind, a lot of different ways to say, but the meaning behind it is that wrap can go on first immediately after that sheathing, or the foam can go on first immediately after that sheathing. So there's 2 different ways to do it, but we'll go over some tips on that. But it's determined based on whether that window is aligned with the exterior wall or if it's recessed. And if it's recessed, you may need a jamb extension. And I think it's important. And when I was starting to work on this with colleagues, I learned a lot about jamb extensions, and they didn't mean a whole lot to me. So I urge you, if you don't know a lot about them, to click on YouTube, go look up some jamb extensions, how they're installed, and really what they're used for. But the main purpose is, A, to give that clean look on a window from the siding to the window, but also to protect the very foam, the very wrap that you've put up from the elements on the outside. So again, things that you may not think about if you've never done it, but they are something that will take some time to learn. And I've seen these done on job site. I've seen them made and painted there, but there are also some that when you deliver the siding, when it's delivered, you order the jambs pre-delivered too. Next. And continued, I think the main thing to take away from this slide, and on the picture in the middle, you can see some test mock-ups that we did at our lab in Richmond, where I'm located. And I'll say that's a pretty cool thing we have at DuPont that's allowed us, including me, to firsthand experience installing these products. So we don't act like we install every day. We don't go to job sites. We don't know everything about it. But when you get your hands on the products and you start to look at the variations in which you can install, you start to learn a lot. But the main thing to take away from this is the difference between a window aligned with the exterior finished wall and a window recessed. So with that window aligned, you're gonna either put the wrap over or under. You could have a wood buck bump out. In this picture, we obviously have a wood bump out there with the foam installed and then the wrap over, and you're pretty much installing that window as if you were with just straight up to sheathing. Now you got to think about it when you're talking about a recessed window and recessed from the exterior wall. And this, for anybody in the Southwest, it's becoming a very common trend there. So architects are really pushing for these new looks, whatever it may be, to keep out the sun, add more shade, just for an architectural look for people. It might look cool to some. What does that add? It adds complexity. So it can be difficult to install, and we understand that, and there are ways in which we have guidelines for that. The one thing to take away from that, though, is to know if you're installing with that recessed with foam, you want the wrap to be behind. And it's key, and really building science follows this, is to have a drainable wrap there. Drainable wraps can range from a non-compressible, like something we have, DuPont Tyvek stucco wrap, drain wrap, or it can be something that's I'm sorry, we are compressible. Non-compressible would be items that have beads on them, or add a little bit of gap from the siding to it. But the way in which that's tested is a test called ASTM E2273, and that's testing the drainage efficiency of a wall and the wrap membrane, and it's tested behind foam. So this fits perfectly with what we're showing here. But you're going to want a product that is above that 90% range, and ours are tested up to anywhere from 98 to 99%, meaning 99% of that water drains after a certain amount of time out of that wall assembly. So it's key when we're talking about what to use behind that foam. We always recommend a drainable wrap. Next. So general considerations first, then we get into fastening requirements. And this is important. First, we're going to show WRB. Next, it'll be the foam, or CI. You need to think about, and this is where we get into that, if it's not something you've always done, you might come to some hiccups on the job site. So thinking through and understanding what you're doing is pretty important. If the wrap's going up first, which is normal to most, and honestly, that was what I thought was always the easiest. I've learned elsewise, so we'll go over a little bit of that later. You can just follow, depending on the WRB manufacturer, their guidelines on temporary fastening. So this completely reduces the amount of fasteners you're using. And I think everybody agrees that that's what we want to hear. So we want to hear, how can we save time, money, whether it be time to put up the product or money for the pieces that we're using. But it's good to know you can follow that pattern, because that foam is going to be put up right after. And now that's kind of your nailing hold on and your wind protection, because you're installing that per guidelines. Vice versa, it can be the same. If the foam's going up first, you can follow a pattern in which it's not complete, you don't have as many fasteners, and then install the wrap per their guidelines. And now you've had that as your protection before that cladding is put up. But it's important to know whatever thickness of foam you're using, if that's driven by your code, if that's driven by the architect, or you the builder, or even the homeowner. If they're thinking through and said, I want a 2-inch foam, you better understand that fastener needs to be that 2-inch plus whatever cladding, plus going into the stud 3/4 of an inch. So a lot of things to take into account when combining these two products, but obvious reasons to use them. Next. Then you get into the continuous installation fastening requirements. And I'll go over some of the keys here. And it's, when you're installing these boards, you have 3 different ways you can install them. One is a 3/8-inch HUD galvanized nail. You can use a 1-inch crown, or the one we highly promote is the 1-inch head plastic cap nails. And what are those giving you? It's just more holding power. So you have more protection on the foam board that you're using. And you're going into that stud 3/4 of an inch behind. We've talked about how can I save some of the amount of fasteners I'm using. I went into a little bit about that, but here are 2 ways in which you can, and you might sit there and go, well, that's nothing. But when you add it to every building you're doing, when you add it to every piece of foam you're putting up, it does add up. So that middle one shows if you're using that fastener 1 inch or greater, you can use it going directly up the board. So right there where it's pointing, you have 4 fasteners rather than what most people would intuitively think. I have to go across one on each board, and it's 8. So think through every single piece that you have. It adds up to a lot. Along with F there, you're taking 2 when 3 boards come together rather than using 1 at each. And it's just ways in which, through testing that we've done, through combined portfolio, through the wind tests, hurricane testing, we've been able to minimize and show that it still has the power that it has. And one thing we learned through working down at the lab was, and it's not a hidden fact, but this foam does not have holding power when you use, for instance, a 3/8" cap fastener that you use on wrap. So on our Tyvek, we recommend that 3/8" staple going into the wrap, into the sheathing. You can't put that on the foam, it'll fall right off. So there's reasons for what we say. All these install guidelines have reasons, and they've been tested too. If they didn't, it would be the Wild Wild West and we'd do whatever we wanted. Next. This is the one that I harped on earlier that I'm pretty passionate about because I think it gets left out too often. But when we start to think about if you're using that foam for various reasons, along with the wrap that you should be using, well, now I got to think about if a plumber or electrician, whatever that trade comes in later in the process when it's already all up, and they say either, hey, I need to move that one over a little bit, it doesn't line up, or we just need to add one on the side of the wall. Well, now we have to think about how are we protecting what we already have up and still having that airtight wall along with protecting it from moisture. So if the wrap's up first, this is where it can get tricky, and this is where it kind of changed our minds, the Heritage DuPont, on, wow, this can get a little tricky when you do this. So you now need to know you have to cut out a certain amount without impacting that wrap behind to flash whatever that pipe is, new or moved, to the wrap on the backside, and then put that foam piece back on. Can it be done? Absolutely. So don't think if I've done this my whole career that I have to change, but we always and highly recommend that you still correctly seal whatever that penetration is. And vice versa, if the Tyvek's on the top, it makes it a whole lot easier because now I'm sealing directly to it, and there's really not a whole lot difference that I'm doing. Next. So this is almost like a cheat sheet. So I think this can be used to picture whatever product you're using, whatever wrap, whatever foam you're using, and it gives you that understanding of, hey, what have I been doing? What are those advantages? And we call them challenges because it's not so much a disadvantage. It's just something that you might have to look into a little bit more and understand. It might take a little bit longer to learn, or it might take a little bit longer on the job site to perform. But when it comes to your wrap under your foam, look at the advantages. So you have a few, you also have a few challenges, more so with the wrap over. What are those advantages? You're able to use that wrap's fastening pattern the way that you always would. So if you're used to using those fasteners from a slap staple, go ahead and use them. So now we don't have to change anything there. And depending on when it's installed, the Tyvek can be used as a temporary fastening like we discussed. The other thing, and I didn't talk about it, the foam provides protection there. So we hear a lot and we see a lot. If you're not taking great care of your job site, things can happen. We're not saying we want the foam to be damaged because that can affect our value, but it's not so much making that your wall is now an area for water to come through because you still have that back protection. So something to think about there. Those challenges are something we talked about before. So the penetrations need to be addressed before. And then there are some complexity around installing bump out flashing. And we'll show you some pictures later that you might not think about when you have the wrap on top. What do you get out of that wrap going over? And I think this is some things you might think about because we didn't at the beginning. You can follow your regular flashing details like Aaron talked about. He changed and understands that I-cut's being used now. If you're not familiar with building practices out in the field, has it been around? Yes, but you still have people doing things that were done in the past. So it's something to think through. It's easier to address penetrations that we've said. So there's a lot less risk when you're installing that flashing around pipe penetrations. And this is a neat one. I think with codes changing, with third parties out there that are conducting third-party reports, with builders. So top builders are now looking at, hey, we need to make sure that our install process is done correctly on the exterior because it does cause problems if not done correctly. and not focusing all of their effort on the interior with what people see. So when they're inspecting that wrap, if you have the foam on top, it's kind of hard to see that wrap if you come later in the process. So again, yes, it can be done, but it's things to think about when installing, to think through, oh man, now I got to think about when the foam's going to be put up and I have to be there on site to make sure the wrap was installed correctly. Whereas if the wrap's on the exterior, you can come look at that process for 4 months before that cladding is put on. Another thing is that wrap protects the foam from UV. So wrap products have a longer UV lifespan. So you're talking roughly 30 days for some of the foams, and wrap, it's anywhere from 4 months to 6 months for some of them. And then when you get into higher products, it's up to 9 to 12 months.
Keenan, we have a question about bracing in the wall.
Yep.
Are you going to address that later on, or you want to?
Oh, let me check. I didn't see. So, Kevin, what more do you mean by bracing the wall? And I'll touch back on that when he sends some more through.
Yeah, Kevin, if you could just retype a little clarification on your question, then we'll get it addressed in a second here. Thanks, Keenan.
Yeah, no worries. And one challenge to think about with that wrap over is, now we're talked about, hey, how long does that fastener need to be? So depending on the thickness of the foam you're using, you've now got to think about the longer fasteners going into that wall with a cap fastener. Now, one pro that I didn't put up there and I thought through this morning was, well, now the advantage of that is I'm going to be using the same fasteners throughout the whole process with my wrap on top. Whereas when you're talking about WRB under, you could be switching if that's the case, but we know we have to install the foam first with longer fasteners and the wrap. So it's all in one, and it's really not a challenge. It's just an easier way to think about it. Next. So then we get into, we've gone over some of those. The last one was the installation sequence when we're talking about flashing windows. Oh, there's another one. So no, fasteners, if I said that, I'm incorrect. So fasteners won't be reduced in the WRB when it's over. Think of it, and I didn't mean to say that, I don't remember, but it's the opposite. So if foam is first, you can have a reduced fastening pattern. Once that WRB is on, you're going to be following its installation pattern, and it's now acting as your holding power there. I hope that answered, David. All right. So we went over and came up with.
Yeah, David says that's great.
Awesome.
Kevin clarified his question. He's saying foam is not structural, so how does a builder incorporate structural integrity? I think that's the sheathing, but go ahead.
Yeah, so you'd be following the same kind of guidelines you would when you're building the home. So it's going to have your structural as the sheathing. We don't see too many places where they don't use sheathing. I know the Southwest has a lot of open stud construction, and what they do is they have bracing on the corners. So it's up to that builder to follow their practices, and they change. So Southwest is just, they're different. They're a different breed. They build pretty much different than most of the country, but if you're ever out there, you'll see some OSB on the corners, and they'll have it sometimes near the windows. That's kind of acting as your bracing. It's giving that home a little bit more sturdiness than it would without anything, but the foam doesn't add or remove any. You're just simply putting up another product to add that R value that you're looking for the energy efficient homes. So looking at the slide we have, we looked at 5 different instances where you'd have various ways in which windows would be installed. And this is another area that, if you're familiar with third-party testing, especially when you're talking multifamily commercial, but even some now residential, they're testing that window because you don't want to put a hole in a wall and expect it to still hold out water. So once you put that hole, you're putting something else on top of it, but you have to make sure that's flashed correctly. You add foam, continuous exterior insulation, to that, and it's one more component that we have to deal with to make sure it's all done correctly. So this right here is kind of a cheat sheet to figure out where's the placement of my window. Is it aligned, recess? Where's the placement of my WRB versus that continuous insulation? Do I have a bump out? And then here's a picture to look at it. And so on the job site, it may be a barrier of language. You might have people only understanding photos, or for people like me who just learn better visually. So we have that, and we'll go through those. One big thing in the note here, it's very important to look at this. So it varies, and this isn't to say what you've been doing is wrong, but it might be something to look at. When the WRB is installed over, and that thickness of whatever insulation you're using is over 1.5 inches. So if you're getting up into the 2-inch range of foam, you're gonna now have to have a wood bump out. If it's less, you don't have to have one unless that window manufacturer is requiring it. So what do you get out of that? Well, around that window, if you're using a 2x4 bump out frame, you've now, like Samantha was talking about, have thermal bridging. There are products out there that reduce it if you're willing to pay. Or if it's, again, less than 1.5 inch, you can directly go to it. What a lot of those window manufacturers like is that you have a solid surface to adhere to, or to nail into or screw into, and it's giving you that holdout power. But testing has shown, and people have done, just foam there, and it works. You just have to be really careful that you're not puncturing it and making the window not level. So next. So here we'll go over, and you'll see on some of the other ones, they have an in-depth discussion on steps. But what you're looking at here on both of these, and the visuals help you see, are windows installed before the wrap, and then one is aligned and one is recessed. So the only difference is a recess and where the foam is put. But also think back what we were talking about, the jam extensions, that's where it might be added on that section too. So you can see on the first one, you have a bump out, foam is installed, a skirt's there for protection at the sill. I install my window directly to that bump out. I flash that window and I put my wrap up and tape it. So the idea and what you're changing is that bump out and the foam difference than when you just put up wrap on a regular wall. On the right, you can see I'm protecting my sill with a skirt there, putting straight up flash or window and flashing. Then I put my wrap, and now my foam goes over top. So we'll show some photos of that moving forward. Samantha? And here's one, and the next slide I'll be showing pictures of it done in the lab like we talked about. But this is an example of what you would see in that bulletin as a complete system. So you have the 6 different steps in the guidelines that you'd follow. And again, these are tested, proven, they work, and the construction's correct. So if there are other manufacturers that do this, by all means, follow it. We just know, and I'm presenting on stuff that we've done in the past. But you're putting up that bump out foam, wrap, installing the flashing, and then putting up the flashing, sorry. Yeah, next slide will show that. And I'm almost finishing up here with a couple more. Samantha, next slide. This goes in and shows you a real world. And ideally, we'd have videos to show this down the road. And in our BKC Building Knowledge Center, we're working on those. But this is a visual to show, yeah, I've got my bump out, foam is installed, wrap it. Now I can flash that window directly to that bump out. Next. And here's foam. The one thing to focus on here is what we were talking about earlier with a drainable wrap. In that picture, you can see a DuPont Tyvek wrap that has crimp product, and that allows for the flat or the water to drain behind. And then next. And 5, I'll go directly. You can go to the visual and I'll talk through. So this is again showing the steps in which it would follow real world, even though it's in a lab, obviously you can tell. But it's showing I'm putting up my wrap first. I'm putting up my bump out. I'm now flashing the bump out. And here's where I talk about the difficulty and complexity in flashing the bump out. It's doable. The first thing you probably look at is price there. Of course, I'm increasing price, but it's definitely very safe, and you're protecting that window probably the most you could. And then the foam is installed over that. So those were the 5 different variations you'd see of windows. There are plenty more, but those will help you in any sense of installing windows. All right.
Oh, Keenan, fantastic. And Samantha, fantastic job. I think that those pictures were so great on how to approach the window openings. And if people, I always think I want my window installers and my Tyvek installers to make sure that they see this as well. So this video is being recorded. It'll be up at the EBA Learning Center. You also can go to eba.org/resources and get to the Building Knowledge Center with DuPont. Keenan, and Samantha, where are other great places to learn more, or is that the best spot for people to go?
Yeah, so we have a lot of that, and currently we're working on a lot of videos to help, tutorials, short videos that'll get to the point. We also have a partnership with CI, and you can download that app for free. And there's not a ton of work done yet on the combination of products, but if you're interested in, for instance, like you just said, flashing a window, there's great videos to show the process visually and with words. To look at that and be able to understand how to flash a basic window or a recessed window like we talked about. So it's just a construction instruction app. It's free. I'd go and take a look at that and look up any type of products you're thinking of in construction.
Fantastic. And then maybe as those recordings become available, the new recordings become available, we'd be happy to share those with our members on the EBA site as well.
Absolutely.
Great. Well, I don't see any more questions right now. So with that, I want to thank you so much for a great presentation today.
Good deal. Thank y'all.
Great. Thanks, everyone.
Thank you.